Quiet, please. Give your attention to Jerry.
Oh, yeah, Jerry. Yeah.
Hey, be nice.
Don lives 3 blocks east of Descartes Avenue and 5 blocks north of Elm Street. Rita lives 7 blocks east of Descartes Avenue and 2 blocks north of Elm Street. Plot points to show locations of Don's house and Rita's house on the board. We label each location with the name and the coordinates of the point.
The interesting thing on that Descartes, that's how you'd say it in English. It's actually a French name that you would say as Descartes, but I heard Memo say it in Espanol. How would you say it in Espanol? Descartes in Espanol. So it is Descartes in origin, but then again, here we go. Find on your graph Descartes Avenue. Rhodes, did you find it? Where's Descartes?
Right there.
Good.
14.
That's pretty specific. Where's Descartes?
Right next to 14 on the y-axis.
It's on the y-axis. So they gave us a description based on Descartes. Maybe that's a main road in that town. What was the other main road they used as a reference point? Elm Street. Find Elm Street. X-axis. So they're looking at where people live in terms of these two main streets. How far away from one, how far away from the other. Okay, so name the street that Dawn lives on. Now, Dawn, let's see. I'm going to find my highlighters. I'm only down to pink. Oh, I got some green. Okay, so Dawn, 3 blocks east of Descartes and 5 blocks north of Elm. So let's go ahead and find Dawn. 3 blocks east. East is this way. North is that way. And they give us a north, south, east, and west up here in the corner. 3 blocks east. 5 blocks north. 1, 2, 3, 4, 5. Put a dot. Let's put a D for Dawn. Now, question A, they say, name the street that Dawn lives on. What do you guys see for Dawn? Oak. And what's the crossroad? Euclid. Oak and Euclid. Name the streets that Frida lives on. So Frida was 7 blocks east and 2 blocks north. So Frida, we have to go 1, 2, 3, 4, 5, 6, 7. 652.
652.
Did you guys get that?
5, 2.
652.
6, 5,
2.
1.
Write it down on the very bottom.
Right there.
Right there. Look.
They get
Look.
Okay, so now Frida. 1, 2, 3, 4, 5, 6, 7 east and 2 north. 1, 2 north. Put a dot. Give that an F for Frida. Andy? Name the street that Frida lives on. Maple and Euler. Bert. Now there's a third friend here in this story. Somebody to read about Bert. Thank you, Andy.
Whoa.
Number 2.
Bert lives at the intersection of the avenue that Dawn lives on and the street that Frida lives on. Plot and label the location of Bert's house on the coordinate plane. Describe the location of Bert's house with respect to Descartes Avenue and Elm Street.
Okay, so as we look at the intersection of the two, here's Frida Street and there's Dawn Street. That's the intersection they're talking about. If we go doot 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 and doot 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 doot, here's the intersection of the streets that those two guys are on. This is Bert. Give it a B. We needed to plot and label the location. Describe the location of Bert's house with respect to Descartes Avenue and Elm Street. So how far to the east are we? How far to the east? 3 blocks east of Descartes. And how far to the north are we off of Elm? 2 blocks north of Elm. How do the X and Y coordinates of Bert's house compare to the X and Y coordinates of Dawn and Frida's house? Maybe we need some coordinates. If we were going to do coordinates for Frida, she is 7 over and 2 up. If we were going to do coordinates for Dawn, he is 3 over and 5 up. What are the coordinates for Bert? 3 over and 2 up. Okay, so how do the X and Y coordinates of Bert's house compare to the X and Y coordinates of Dawn's house and Frida's? Let's look at them one at a time. Bert's house, how does he compare to Dawn? Looking at coordinates, what do you notice? 3 where?
They live along the same road.
Bert's house has same X coordinate. They do live along the same road, and the road that they live on is located at 3 on this little coordinate plane. The road that they live on is Euclid, and in both cases they're 3 over from Descartes. Bert's house has, now if we compare Frida, 3, 2, and 7, 2. How does his thing compare with Frida? Same Y coordinate as Frida. Now I heard a 4. What does 4 have to do with this? That's great. That's a nice observation, and I believe that's one of the things we're going to next, so it's a good segue.
It's the block between Frida and Bert.
That's how many blocks. If we're not comparing it to Descartes and to Euclid anymore, but just to each other, they're 1, 2, 3, 4 blocks apart. How many blocks apart are they right here? 3 blocks apart. Now we can see that with our eyeballs. How else could we have figured that out? Coordinates. What about the coordinates? Subtract 7 and 3 to find this side. Subtract 5 and 2 to get that side. Okay, Don and Bert's coordinates. Number 4. Use Don's and Bert's house coordinates to write and simplify an expression that represents the distance between their house. Explain what this means in turn of the problem. So Don and Bert. Don and Bert are over here. And if we want to find the distance between their houses and we're using coordinates, what coordinates do we need to work with? Andy, quit playing. Look at your chart. Don and Bert, D and B. What did we just say you could do to find how far apart they are? Subtract. What two numbers are we going to subtract? For Don and Bert. Everybody put your finger on Don and another finger on Bert.
Alright, there would be 1, 2.
What do we need to subtract to figure out how far apart they are?
5 and 2.
5 and 2. That's what they're asking us to do up here. 5 minus 2 equals 3.
3 blocks apart.
Don lives 3 blocks north. Bert and Frida, put your fingers on B and F. Look at the coordinates. What are we going to need to subtract? You have the coordinates written down on your graph.
7 and 3.
7 minus 3 equals
4.
4. Good thing Memo came today. He's king of the class right now. 7 minus 3 is 4. So Frida lives 4 blocks east. Okay, all 3 friends are planning to meet at Don's house to hang out. Frida walks to Bert's house, and then Frida and Bert walk together to Don's house. Let's look at that. Frida, where is she going to go? Frida walks to Bert's house, and then the 2 of them walk together to Don's house. Use coordinates to write and simplify an expression that represents the total distance from Frida's house to Bert's house. What? Use coordinates to write and simplify an expression that represents the total distance from Frida's house to Bert's house to Don's house. How far in blocks? What?
Just said this confused me.
It's confusing me too. Oh, okay. Here, it's not that confusing once you think about it. Okay, first of all, Frida is going to Bert's house. Then they're both going to Don's house. How many blocks is it this way from Frida's house to Bert's house? 4. How many blocks is it after they have to turn and go up together?
3.
3. What are we going to have to do to figure out the total distance that they walk?
You gotta add them.
Oh,
So 4 plus 3, I think it's 7.
7 total blocks.
That's a long way.
Okay, so I already answered this part. Draw the direct path from Don's house to Frida's house. So back to our graph. Here's our ruler. Here we go.
Mr. Gary, isn't that trespassing though? Going through property?
It looks like we might be hopping some fences and going through some backyards here. It all depends on whose house it is, whether they'll allow it. I agree. We may be trespassing if we do the direct route.
What about
If Frida walks to Dawn's house on this path, how far in blocks does she walk? How can we figure this out?
It looks like a triangle.
It looks like a triangle.
I wonder why.
Indeed it is. And then you got the hypotenuse.
Oh, where's the hypotenuse?
From Frida all the way to Dawn.
Oh, this is a hypotenuse.
And then the two legs are from Dawn.
Hypotenuse isn't a special kind of triangle. Not all triangles have a hypotenuse. What kind of triangle has a hypotenuse? A right triangle, and hypotenuse is opposite. So there's our right angle. Ha ha ha. If we want to know how far apart their houses are, what can we do? Do we add? Do we subtract? How do we get that? How do we get from here to here?
You square rooted.
It's something with squares. What do we know? Here, wait. Maybe we need to draw in the rest of the triangle to make it look like something we know what to do with.
Oh, I already did that.
You're ahead of me?
Yeah.
Okay, here's the deal. We want to know what this length is. I know you can do it. I know some of you have spaced out at the moment, so I'm going to turn it back to you. 1 minute at your table. How can we figure out how long that distance is? Straight line distance. We know this side is 3, and we know that side is 4. I'm coming around. Find a solution. Show your work in number 7. Show your work right here, please. What we gotta do here? How far apart are these two guys?
Look, right here.
How can we find that?
I just
How can we find that length? You guys got it? Don't look like you want me to use that. You guys on it? Good.
5 blocks. Oh, you gotta like put 25. Look. It's 3
There we go. I knew you could do it. Okay. Brody, what did we get?
5 blocks.
5 blocks. Oops. Brody has 5 blocks. Do we agree with him?
Yes.
What's the formula we set up to get that?
Ooh, I got your back.
Yes.
So you square 3, which is 9, and you square 4, which is 16. Then you kind of add those two together. And you get 25. Then you square root that, and you get 5.
Okay. So now, let's see what else they want to. I think one thing to notice here before we move on is when we got that 3, that was the difference in y coordinates. Coordinates. This was the side where both points were on the same street, Euler or something like that. When we got the 4, that was the difference in the x coordinates. Those were the two that were on the same street on the same y. Difference in y coordinates, difference in x coordinates. We squared them, added them up to find a diagonal. It didn't have things similar. It was cutting sideways. All right, flip the page. So we found that 4 and 3 by a little subtraction. For Frida's house, we subtracted 7 and 3. We're writing into some little rectangles right here. For Frida's house, we've subtracted 7 and 3. That's where we got the 4. Squared it to make 16. For Don's house, we subtracted 5 and 2. We could tell on one coordinate they were exactly the same, but how far apart they were, we used the other coordinate. That's where we got the 3. Squared it, we got 9. Okay, direct distance. I say this doesn't make sense, that doesn't make sense. Right here we have 25. Okay, and then we ended up with C equals 5. I don't know what they're doing with all those other boxes. Okay, but we're trying to backtrack through an idea that we did subtract coordinates to get this side. We subtracted some coordinates to get that side. And we used the result of that subtraction with our Pythagorean. Suppose, now it gets, do you have that? Should I not put it up yet? A couple people still writing. Now, suppose Frida, Bert, and Don's houses are at a different location. Look, they've been moved. Everybody moved, okay? You can generalize the locations by using x1, x2, y1, y2, and still solve the distances between their houses. So now we're taking the numbers out of it and trying to look at the pattern that we could easily see on the grid, but now we're going to make a formula. Dawn's house to Bert's house. So I'm looking at these two houses first. Look at the coordinates. Which of the two coordinates is exactly the same? They're both Dawn and Bert. So the x or the y, which of the two is exactly the same?
The x's.
X's are the same here. So if we're going to figure out how far apart are they, what are we going to subtract? No.
The y's.
We're going to subtract the two that are different. Okay, the two that are different is how far apart are those different y's. So right here, dB, we're going to go y2 minus y1. Hello?
It's me.
Please write that down back there. Okay. Now, if I'm looking at Frida and Bert, look at the coordinates for Frida and Bert. It's a little more difficult when they don't have numbers in there, but the pattern is 2 of the coordinates are exactly the same, and 2 of the coordinates are different. Who are the coordinates who are exactly the same? The y's. So we want to figure out how far apart are the 2 that are different. The BF, or the distance between Bert and Frida, what are we going to do for a subtraction?
Just subtract the x's.
x2 minus x1. The numbers that were different were like the 7 and the 3. You could see right off the bat that 7 and 3 are 4 apart. It's a little bit harder to see when we're using letters instead. But you could see, oh, I know how far apart that is. You subtract. Use Pythagorean theorem to find the difference between Dawn and Frida. So what we did is we took the one distance, which you can find by subtracting, and squared it. Then we took the other distance, which you can find by subtracting, and squared it. We added those together, and then what did you have to do for a last step? That equals df squared, right? What do you have to do to get the diagonal distance all by itself? df equals, what's the last step in solving a Pythagorean theorem thing? Square root. So here's what you need. Square root of y2 minus y1 squared plus square root of x2 minus x1 squared. The distance on the diagonal, do you guys have this written? I was going to look at that picture one more time. Oh. We can just look down. Yes, we can. Okay. If we look down, what we've just done with Bert, Frida, and Dawn is what's called the distance formula. Distance formula. Da, 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 da. But here's the key idea. On the legs, on one side, you're subtracting the two y's. On another side, you're subtracting the two x's. To figure out the hypotenuse, you square both of these, add them together, and then you have to take a square root to get that hypotenuse. That is probably way more than your brains can hold. Maybe a tiny piece of that sunk in. We'll re-look at this again. But we've used coordinates and Pythagorean to figure out a distance between some points. Okay, I need a collection of stuff. And then, wait a minute. Your ticket out of here is we're going to line up by partners, and you're going to tell me question 2. So you're going to put away books, rulers, calculators, get with your partner, and know what your question 2 is.
Andy Berry.
Yeah!
You're